My name is Hui Yu. I am a software engineer at RubyConfTH. So I attended this Ruby conference last year, and I have inspired a lot by many awesome speakers and this Ruby community. So I submit my proposals this year and got accepted. So this is my ID to LinkedIn, Twitter, GitHub. So that is my full name in Vietnamese, Yu Ya Hui. So exponentdev.com is my personal website. So what is programming? Programming involves solving problem by providing instruction to the computer. So if you joined the talk yesterday about delegation, it means that we are delegate our job, our solution to computer to running it. And I am very sure that everyone here have familiar with the basic concept of mathematics. So if we representing programming in mathematics is fx equal to y, which is fx is solution to the given problem we are trying to solve. X is the input to the problem and y is the expected outcome. So based on that, what are errors? So we're running the function f with the given x. So however, if the outcome of fx is not equal to y, it's maybe z or anything. So it's not match our expected result. So that is errors. So software error are unexpected outcome from the computer programs, and it's caused the program executes in the different way that were not intended. So in general, we have two types of errors. Expected error is the part of program execution. As a software engineer, we have to expect error to happen during program execution, or at least we have to predict the possibility when it happens in the future. So expected error could be a part of business logic. For example, if we create a web application for selling a ticket to this Ruby conference, the error could be ticket have been sold out, purchase ticket cannot proceed after the midnight, for example. And it's maybe come from the external dependency, like we use library in the wrong way, or the networking issue. So unexpected error, in the other hand, definitely not expected to be happen. It will interrupt our program execution and also known as defects, bugs. Unexpected error always with 100% accuracy that the error we encountered was not fully anticipated by developer. So it can be the developer mistake, whether they are implement wrong logic or they don't handle for specific behavior, so the error occurred. So it can be the thing that we cannot control. For example, the database corrupted, memory exceeded because it's related to the infrastructure. But eventually we can prevent it to be happen by monitoring, improving our observability for our software. So in this talk, we are not covering the unexpected error. We will cover the expected error and we handle it well. So if we handle expected error very well, then it would easy for us to handle unexpected error. And finally, we avoiding disaster, prevent the incident happening from our production environment. So let's quick look through the exception in Ruby. So exception is the unique data structure that representing error in the Ruby programs. It carries three things: type, message, backtrace. So I give this piece of code for visualize how exception work in the Ruby. So I just using the create a divide method x by y, and if the division raising an error, I capture it and print it out. So due to the execution, the result will be new. So I raise exception with a different. And finally, I intentionally divide 10 by 0 to see what happened. So in the console, we can see the exception is raised and carry the information about type, about message, backtrace. And because we raise an invalid result error as well, so eventually it's hurt our program from executing. And because Ruby is interpreter languages, so whenever we execute the code from the call stack and its ready exception, it will popping up through the call stack until it found the execution. Otherwise, our Ruby program will be disrupted or stop from executing. So with those basic information, we step into the example problem. So let's say I want to build an application with the given user story. So as a user, I want to buy a ticket to attending Ruby conference. So because we are living in the Ruby community, and the most successful story about Ruby is creating web application with Ruby on Rails. So let's just assume that we need to deliver the web app. And actually, it's not only limited to the web app, but in this particular talk, I choose the web app for everyone because mostly everyone is familiar with it. So firstly, with the simple example, we need to coming up with the high-level system design. So it's very simple, like just have a front-end, API server, and a database. So the user interact with the UI in the front end for buying a ticket. Front end will send a request with the user ID and the ticket ID so that we creating order in our system, in our backend system. And backend system, it interact with the database, we manipulate data. And we also use the third-party payment gateway to supporting the monetization. So I think it's very simple flow to represent the develop this feature. So coming up with the in-memory application component. So the most basic architecture we will do is the MVC. But because we don't care, we fully focusing on the backend side and we don't care about the front-end side now. So we just use the controller and model. So model interact with the database and the controller interact with the payment gateway. So with that, I come up with the naive implementation by putting everything in the controller. So don't be afraid to reading that code. I will explain line by line to save your brain juice. So, okay. So for buying a ticket, we need to submit the order user ID and ticket params. So we find the user and ticket based on the request param. If there is no issue, we will create an order with the given user and ticket. So next, we check the user balance. If enough to make a purchase, if yes, we will submit the payment to the payment gateway. And finally, the payment succeeds, and we return the successful response to the user. So that is the happy part. Now about the error part, if the user balance is insufficient, we're rendering the error. And next is the execution part. Because we use the find method and the bank method for the create, so it will raise exception when anything invalid with those parents. So we just rescue it and we return the error to the user. And the same thing for the payment error. We also catch the exception and we return the error to the user. So because it is the naive implementation, so what do you think about it? Like, it's very chaotic, it's very error prone, it's poor extendability, poor readability, not reusable. So can we make it better? And we realized that we need something in between the without this advantage. We need to encapsulating the solution within the not express everything in the controller. So we create a business logic layer. The model still interact with the database, but we create a boundary between the controller and model, and we wrap the logic into the business logic, and it interact with the payment gateway. So the controller just calling to the business logic, and we can reusable it. For example, we not only using in the controller, we can using it in the background job. So the question why we need business logic is because it's keep on our business logic localized in one place. So future chain will be much easier at a result. And it also allows you to easily unit test your business logic. And of course, it's easily to reusable as well. So this is the controller implementation. So I'm trying to break the logic down into smaller species. So I create the create order service. Then I wrap the submitting payment to the checkout order service. So I also catch the exception inside those service, and I return the error to the outside. And you can see in the checkout order we have two type of special value for indicate the error. So it's the insufficient balance, and the value we return fail when the payment rescue the payment error. So apply it into the controller. So we can see now in the controller we don't need to rescue the exception because we already handle it in the services. But the thing is, we can see we have too many types for indicate an error. For example, in the checkout order service. So this is the flow. I visualize it. So it's the same logic, just a better encapsulation. So we check the create order. If it's value with return error, then it succeed. We continue to check out order, and we check the insufficient balance error, and we return error. And if not, we check the payment error, and we also return. And we return successful is all the thing go to the happy path. So now it's a lot more readable, better code flow, but there's still issue, right? So the issue is come from the different type of error. So is indicate is we return the inconsistent value, and there is no standardized for that. So, and this is very important because we are not delivery software alone, except you are the solo developer, so it's fine. But we have to collaborate with a team, and each person in a team have a different opinion on solving problems. So some person may want to return it as string, or use symbol, or just use the null value to represent error. So even it may leading to conflict between the team member just because of the convention. And the second problem is we expose too many type of error. So in the controller, we still need to handle many type of error, and we need to understand the logic inside the checkout order. So it's still not reusable. So with the refactoring, we have the better code flow, better readability, better extendability. However, we still have a poor encapsulation, and therefore it's not reusable. So how to resolve it? So we can resolve it by return a monad at a result. So what is the monad? Monad is the structure that wraps the return value in the function in the monadic way. It acts as container that hold a value and define operation to manipulate that value. So in simple terms, we can just refer to either 0 or 1, true or false, success or failure. Like we always refer to either of two. We have no choice. We force everything into two options. So it's allowed us to structure our error handling in very simple way. So with that definition, how to apply into Ruby. So we want to apply it. We need to understand the monad result. Monad result is the object that contains either success result and the value, or failure result and errors. So represent it in Ruby is we can just use the open struct to build the monad result. So struct had two attributes, successful or fail, that can be used to check the result of the service. The success result is contain the result key attribute or expected outcome. And the failure, in the other hand, is contain the error that caused, represent why it has been failed. So we can use the monad result to handle error or conditional operation or complexity business logic in a functional and structured manner. But it's still not so powerful if we only return the monad result. We have to combine it with something. So we use it with service object. So what is service object? So it's the Ruby object that's designed to execute one single action in the business logic, and we do it well. So service object contains a single public method that performs a specific action. It encapsulates a set of operation, validation, calculation, or anything you need to develop your business logic. It provides a well-defined and well-reusable API for the other part of Ruby application. So in the refactoring earlier, to represent the business logic, I also do it with some sort of service object, but it's still not in the proper define yet. So this is the example. So create order, we're wrapping it inside the class. So now is the important part, monadic handling. So the combining between the service object, monad result, I'm calling it as monadic handling. So in this context, monadic handling involves using the service object to encapsulate a single action of business logic, and then we use monad result to represent the outcome of service execution. The monad result used to be managed both successful and failure case in a structured and composable manner. The service object returns a monad result which can be composed, processed further in the predictable and consistent manner. It allows you to avoid using exception for error handling and encourage explicit handling both success and failure scenario. So how do we can create monadic handling in Ruby? So we can create a base class. I call it like monadic service for all service that will be adopted by monadic handling. It's the bootstrap service. And in our application, Ruby application, we can call it like a application service. So this is the constant of the monad result. We encapsulate the business logic into the public method call. So and we always putting the logic inside. And if we don't implement the call function, it will raise and not implement error. So if the service was successful, the result attribute will contain the result of the service. Or if service failed, the error attribute will contain the error that caused the failure. So now we will apply monadic handling. This is the refactoring the service object we create earlier. Then we apply it with monadic handling. And first, we create order as a child of the monadic service object. This is the result of refactoring. Then we wrap it into the monad result, succeed and the failure. Same thing for the checkout order. We do the same. Make it the child of monadic service. For the error, we making it as failure. And you can see the true font value now we can standardize it by just either success or failure. So compared to, so this is the controller after we applying the monadic handling. And so you can see compared to the naive implementation now, the code is visualized a lot better. So the flow now is much easier. So we buy a ticket. Then we just checking for the error and we render it for the create order. Same thing for checkout order. We also check the error and we return. Then we return a successful response to the user if all things go well. So with this monadic handling, we provide a standardized and consistent way for error handling. We explicit and reduce the complexity of conditional case, making the code more robust and maintainable, completely encapsulate logic and reusable everywhere. So now some people still may think it's still not enough for me to apply for my application. Like why we need to do it. So for the error handling, in general, we can handle error in just two concepts. Well, let's say we come back with the formula in the beginning. We have the input value x. So before we perform the fx, the x must have a valid criteria, must be in the valid requirement before we can resolve that problem. So if the x is valid, so we need to make sure that expected outcome will always be equal to y without any issue. So with those two concepts, that is validity and execution. So validity is about the thing we pertain to issue related to the inputs. And there are errors that occur when the input does not conform the expected or valid input defined from the problem. So error handling for validity involves checking and validating the input before it can be processed in the function fx. So this is where our monadic handling play a crucial role. So for example, if your problem requires x must to be positive integer, so validity error would check validity error handling would check if x indeed a positive number. Otherwise, we will early return the failure. So we can map the validity error with the expected error we discussed in earlier. And about the unexpected error, we map it into the execution error. So execution error refer to issue that arise during the execution of the function fxl. So after the validation passes, we have enough criteria to perform the execution. But if there any error during this execution, is definitely unexpected and developer didn't anticipate it. So in this case, our error handling should catch the exception, handle it gracefully by logging detail for debugging, and report the error immediately to the developer. So we knowing about the where we do the monadic handling. And when you use monadic handling, it should be cover almost everything expected error from your end. So if there any error you feel that is critical, it may happen during the execution. So before raising it, we need to ask 3 questions before raising. So is this action truly unexpected? Am I going to disrupt the execution flow? Will have the hard attack when this exception throw? Because if you following my strategy, when you see exception happen in your app, your heart will stop spinning for a couple of seconds because we do all the things for the expected error, but now something badly happened and we don't know what about it. So that is the strategy. So for the wrap up, so in this talk, we understand the different type of error in software application. We understand how exception in Ruby works, and we create a boundary for business logic layer, encapsulate it with service object, and we use the monadic error handling by combining service object and monad result. And more importantly is you have the practical strategy for error handling. So is in the end this talk. Okay. So break is not prevent your system from crash. You need melodic handling. Okay. And salute.